Well, hello everyone, this is KP the Math G. We are looking at the final part of the 2025 free response question number 4, where it says find the absolute minimum, if there is one, of course, on the interval from -6 to 12, including -6 and 12. There is an extreme value theorem where we know that the extreme value theorem says if there is an absolute minimum or an absolute maximum, you will have to try the two endpoints. So one thing we need to find. Alright, so what we're going to do is we're probably just going to flip this thing over, and we're just going to have to go back and forth. That's just the only way I can justify doing this. So let me flip this around, and I did not realize I had this. Sorry about that, but that will not take too long to erase, so we'll just do that. So bear with me just for a moment. We are looking at the interval from 6 to x, and we're looking at alpha t. This is g at x, alright, equal to alpha t dt. Again, t does not necessarily, not always does it mean time, so just bear that in mind while we're doing this together. Alright, so what we're looking at is we are going to fill in a table, and I'm just going to show you how to go about it. Now remember, this is the graph of G, so that's what we're wanting to find. Okay, so we're looking for an absolute minimum. Absolute minimum. If we're looking for an absolute minimum or an absolute maximum, what are we to find? What are we to do to this equation here? We've got to do something with it. Yeah, we've got to find the slope of that, don't we? What is that slope supposed to be equal to? Yes, you're right. If you said 0, that's exactly right. Because if you have an absolute minimum, here's your slope right here. Slope of the tangent line will be m equals 0. This would be, well, let's say we have something that looks like this, and this would be the absolute minimum right here. Absolute min. Alright? An absolute max would look something like this. This would be the absolute max, and its slope there, m is equal to 0. So that's what you're wanting to do. You want to find the derivative of g. Now, as complicated as that may seem, it's not as bad as it looks. So we're going to take a look at, so we already know that it's on the closed interval, and a lot of times they'll just say -6 less than or equal to x less than or equal to 12. So we know we need to put the endpoints. So -6 and 12 are the two endpoints. Now what we need are what we call critical numbers. Those are numbers in between. Alright, so let's see. After we set this equal to 0, we're going to do it. So g prime, that's how you do the derivative of the left side. Just put a prime sign on there. That's it. That's all you do. Now when you take the derivative of an antiderivative, just all you got to do is put that x. Don't worry about that 6 right there. Derivative of a constant is 0. So that's just f at x. And you got to show that, and we know that that's going to be set equal to 0. We want to look on here where f at x is equal to 0. That's all we're looking for. Let's go to that, and then we won't need to look at the graph anymore. Alright, so we have two Alright, now we're looking for critical numbers right here. Where is F0? Well, we know it's at 0, and we know that it's at 6. So we have everything. And nothing else is at 0. We're looking at the x-axis when you're saying, or like y is equal to 0, which is the x-axis. Where is that? Well, F is 0, at 0, and it's 6. And that's what you got to know. That's what you got to be able to do. All right, so let's turn it back over. Ooh. You know, folks, I don't have very much here, but I love what I have, and I'm grateful to have it. Okay. Now F is 0. It's at 0, and it's at 6. These are the critical numbers. Critical numbers right here. Right here. These are the endpoints. Why do I use endpoints? Because our extreme value theorem says it to look at the extreme ends. So we have to look at endpoints and critical numbers. If you don't get anything else out of this, know that you got to do that. Okay? And then, of course, this is where f at x is 0. Once again, we found that it crossed the x-axis at 0 and at 6. I'm going to flip it over one more time to show you. This is a beautiful problem. I used to be scared to death of these problems, but not much anymore. Okay? And so right here and right here. That's all you got to know. We're not looking at where the slope is. No, we're not looking at that. Where is F0? That's what this says here. When I took the derivative of both sides, I got F, which is G prime at x. It makes me have F at x. So F at x is equal to 0. Alright, we're going to need a little room here. You need to have this somewhere. Let's put it up here. Alright. Critical numbers, x equals 0, 0, x equals 6. Alright, our critical numbers are here. Endpoints. Oh, I don't know. I don't know endpoints. I say I don't know. I do know. Endpoints are at x equals -6. Those are the extreme ends right here. And 12. That's what you're looking for. Alright, x is equal to 12. Now you have 4 to look for. Now you got to find g at x. So don't let that fool you. That's g at x each time. So g at x is equal to, well, we know what it is. F at 6 to x, F at t dt. Alright. Well, let's find it. G, let's start at -6. At -6. Yeah, we're going to have to flip this thing back over. And that is from 6 to -6, F at t dt. Now, what's wrong with this? Yeah, this is not in the correct order, is it? So what do? What's the rule for this one? They want to test to see if you understand integration rules. Alright, so we got to flip it over. Got to put the negative on the outside. And we're going to make this -6 to 6, F at t dt. Just remember that rule right there. When the bottom, the lower is larger than the higher, then we gotta put the negative sign in front, and then we can switch those around. That's a rule right here. Now we're just wanting to go from -6 to 6, aren't we? Alright, so let's look at that. We're going to fill in this blank right here. Okay? Let's do it. Of course, you got to show your work. I'm going to have to erase this from time to time. So here we go. Let's look at it. So from -6 to 6. Okay, here we go. Negative 6 to 6. Well, can you see that this area is below the x-axis, and this area is above the x-axis right here? And so whatever we find for this one, this is going to be the negative. If it's below the x-axis, whatever area we find down below the x-axis is going to be negative, and whatever we find here, both of these are semicircles. Now I know it doesn't look like it because PP to Math G didn't draw this to scale. Looks more like a parabolic thing, but it doesn't matter. Anyway, any way you look at it, this may look a little bigger than this. It's not, though. They're both the same. And so, all right, this area is the same as this. This one's negative. This one's positive. These, you might want to say, cancel each other out. So when you find the same thing down here as you do up here, don't fret over it. Don't try to figure it out. You don't have to. Okay? Okay, so this, I already found it. This is equal to, alright, so negative 6, negative f of t dt. Well, we don't have to worry about the negative sign. This is negative 0, which we might as well just say is 0. Okay. This answer right here is 0. Now what we're looking for, this is the y value in it. Which x value is going to make the y value the smallest? You hear me? The lowest. Is 0 the lowest? We're going to find out. Alright. Well, I have to erase this. Alright, because now we're doing x being 12. Now always remember, you go back to the original. See, this is g right here, so you have to plug this into here. Well, right here. You got to plug it into here, right there, and then you got to find it, okay? Not here, but here, okay? So here we go, g of 12, 6 to 12. We already have it in the correct order. We don't need to flip-flop it. We don't need a negative sign. F of t dt. Alright, g at 12. I'm going from 6 to 12, so let's take a look at it. I think that's going to be a triangle. And it is. So right here, this is a triangle from 6 to 12. Alright, so I want the area of this. I know the area of a triangle is 1/2. The base, 6 to 12 is 6. The height, we know, goes all the way to 3. So 6 times 3 is 18, and half of that is half of 18, which is 9. So I know that this area is 9. Now, what do you know about g at 12? We got the answer is 9. So far, compare the two answers. So we got to get all 4 of them first. What do you know about this one? Is this an absolute? Now remember, we're looking for an absolute min, not an absolute max. So far, this would be the absolute max. I think it is. But we're looking for the absolute min, so this one does not work because we already know that 0 is smaller than 9, don't we? Cannot use that. Okay, so no, we cannot use this. I'm just going to put a circle around the x. Okay, no, we cannot use that. Is this okay? Maybe. Alright, let's look at the next one. Alright, so now we're going from, okay. Now, you know what to do here by now. From 6 to 0. Okay. Plugging in 0 right here now. Always just go to the next one once you get one done. Alright, so here we go. We know this is 6 down here. That's part of the problem right here that I kind of... Alright, there's your 6 right there. X, so whatever X is, plugging that in. You know what to do here, don't you? Absolutely. We flip it over, put the negative sign in front first. Now we can flip it over. Can't just flip it over without the negative sign. And we still call it alpha t dt. Don't make this complicated. Make it alpha to x. I don't think they're going to count off if you did. But just, it's alpha t. There it is right there. It's whatever it is. That's the negative of that. So we're going to go from 0 to 6. Alright, so here we go. Whatever answer we get, we're going to go to the negative of that. Alright, here we go. From 0 to 6 is this region down here. It's a semicircle. You need to know the area of a semicircle, don't you? Well, the area is equal to 1/2. Because it's a semicircle. It's not a full circle. Pi, the area of a circle is pi r squared, so a semicircle is 1/2 pi r squared. R happens to be 3, so yeah, it's -3. Well, radius is positive, so we're just going to yeah, there you go, right there. 3 squared is 9. So remember, the only thing in the denominator really is a 2. Alright, so we have 9 pi, all that's in the numerator, over 2. But remember, we are taking the negative sign. Alright, so that's what we're going to do. So negative 9 pi over 2. So whatever we found this to be here, we just took the negative of that. So negative 9 pi over 2. So right here, negative 9 pi over 2. Well, we're looking for the absolute minimum. I think I can erase this question mark now, because any negative number is smaller than any positive number. Well, in this case, neutral, whatever you want to say. So that one there, no good. So far, this one may work. Let's find out what happens here. Now, they're testing your ability to know the rules. Okay, so in this case, we're going G at 6. Alright. I do not have to flip this over. And I think you know why I don't have to. Alright. Oh, let's put 6 up here. Anytime you have the same bottom and top, wants that answer automatically. You got it. It's 0. Alright. This answer 0. There it is. Well, we got 2 of them. This answer 0. So guess what? I can erase this. Okay. Now you might want to say something here. You can't just leave it like this. You say, okay, the absolute minimum of G is where when X is equal to what? 0? You might say occurs at X equals 0. There it is. Neat little problem. Now, again, you're making sure that it does ask for, it says find the value of x. Alright, the absolute min. Absolute min means you find the derivative you need to show. Well, I must have erased it. Well, in case we have, it's alright. We do have g prime. You gotta say, g prime at x, that somewhere needs to be in there, equals f at x. And since we're looking for max or min, either one, you're going to say equals 0 right there. I think you get a point for that. Alright, you get probably a point, maybe just one. If you recognize the critical numbers and you have the endpoints going for you, you can probably get a point for that. Now, it's left up to you to understand you're looking for G, alright, which means you got to use this, you got to plug it back into the original right here, okay? And then you find out, since you're looking for a minimum, which number is, which one of these y's is the least of them, okay? In this case, this is the only negative one we got, okay? And then now that is going to be at when x is 0. Well, that's it. That's all you have to do on that one. And I know this may be a little bit for you to swallow a little bit, but that's okay. I think if you follow this, start with this, f is at 0. When we saw that graph, the critical points were 0 and 6. So if you got those, don't think too hard about it. That's where that intersected the x-axis at 0 and at 6. And then you already had the endpoints, so you got to use the extreme value theorem right here and the critical numbers here. You happen to have 4 of them. You got to use all 4 of these in this formula right here. Where this x is, plug in -6. And remember, when this number's smaller, you got to put the negative sign out in front. It didn't matter because it was already 0 here. Okay? You plugged in 12, you had a triangle. This would be an absolute maximum, wouldn't it? You see what I mean? This is your absolute max, but keep in mind you don't have to tell them that, because you're looking for the absolute min. So bear in mind which one you are looking for, and then just take it and plug each one back into the original. That's what you do. Hey, it took me a while to figure that out, but I did. You know, I finally got it. I'm not going to lie to you about it. It took me a while. I knew I needed critical numbers, and I knew I needed the endpoints, but then, oh, what do you do next? I'm scared. No, don't be scared. You're looking at G right here. And I almost believe there's a few problems. There's so many of them that you can do, but you just about get a guess somewhere on your test. But it may be in terms of free response that you get this on there. You know, I almost want to think you're going to get something that revolves around an axis. I almost want to say that you're going to get maybe something that deals with a particle or something, you know, or maybe 2 particles. You never know what you're going to get on these. But hey, don't panic. I've already done some videos on that. And I have some other videos from I want to say this was a 2025. I have numbers 5 and 6. And I don't know where I'm going to go from there, because I'm going to be through with all of these. I want to try to get, this is going to be my 170th video right here. So, I mean, I can't do 2026. That's the test you're going to be taking. I might can pull some other stuff that I haven't done yet, but I have to look at the others to see which ones I haven't done. So, but anyway, be that as it may, that's the only thing I'm doing. I do have at my availability some old questions from another book that I can use, and I do have that, and I might could just kind of fish some of those out, but maybe if I can kind of work it up to 180, 190, maybe 200 problems, that's probably where I'm going to stop right there. I don't know if I will or not, and kind of get something else, maybe college algebra or something like that. Be that as it may, we'll see. Okay. Damn. I have a cat that loves to jump all over thinking that this printer and stuff is her stool or something. I don't know, but anyway. Yeah, we have a couple of cats and one dog, and I tell you, they all have character. Believe me, a certain character about them. You love them all. Okay. I trust this has helped you out right here. This is KP the Math G getting ready to sign off. If you have not subscribed, please do so. If you have, if you'd like to make a comment, please make a comment. And if you'd like to hit that like button, I tell this every time, don't I? If you've already seen me before, I always have that smile on my face, even while I'm talking about that like button. If you don't want to do any of that, so be it. It's okay. It's okay. Alright. I'm not one to be a stickler on hit that subscribe button. I like that, but if you don't, well, okay. Again, this is for your benefit, not for mine. I'm not here to make money or anything like this. I'm just here to do this, and it keeps my mind sharp also. You know, it keeps me sharp on what I'm doing here, and it does help me out tremendously. Anyway, KP the Math G signing off. Ladies and gentlemen, have a great day.